Kia ora everyone, this is almost everything you'll need to know about the muscles of the leg. There are 13 muscles of the leg, which is an uncomfortable number, but happily they're split up into 4 compartments, and no compartment has more than 4 muscles, so that makes it much easier for us to remember. Looking at this view, initially the most interesting feature we see is not the muscles, however, but this bare area of the tibia. This is the medial surface of the tibia. No muscles have their proximal attachment to it, and it's a very useful landmark because it separates the anterior compartment of muscles here from the posterior compartment of muscles here. The anterior compartment is the extensor compartment. The posterior compartment is the flexor compartment. The other compartments aren't separated by bone, but are separated by the interosseous membrane or other thickened fascial layers called intermuscular septa. If we look at the leg from the lateral aspect, we can't see the intermuscular septa, but we can see the 3 major compartments altogether. Anterior compartment here, whose tendons all play across the front of the ankle joint and the dorsum of the foot. The lateral compartment here, whose tendons course behind the lateral malleolus. And once more the posterior compartment here, or at least one subdivision of the posterior compartment, because it is the posterior or flexor compartment that is divided into 2 subcompartments to give us our 4 compartments overall. The muscles are divided into a superficial group, which are the ones we can see here, and a deep group, which are more evident, or which is more evident when viewed from the medial perspective. The muscles of the deep group are sandwiched in between the superficial group and the posterior surface of the tibia, and the tendons of these muscles can be seen here coursing behind the medial malleolus, whereas the distal aponeurosis and tendons of the superficial subcompartment all form this large tendon, which is the tendo Achilles, and attached to the calcaneus here. The muscles of the deep compartment actually do extend up to the proximal leg, and if we take a dreaded axial section through the leg at about this level, we'll be able to get a better understanding, hopefully, of the organization of the compartments and the septa that separate them. We'll start by drawing the tibia, and it's connected to the smaller fibula. This is the interosseous membrane. You may recall that the tibia has an anterior border, a posterior border, and an interosseous border, and the fibula has the same named borders, anterior, interosseous, and posterior. This is the medial surface of the tibia, which will be the subcutaneous surface, and this is a lateral surface. This is the posterior surface. The fibula also has a posterior surface and a lateral surface. This surface tends to be called the anterior surface rather than the medial surface in the fibula. Certainly in the tables in your books, that's how it's referred to. From the anterior and posterior borders of the fibula arise anterior and posterior intermuscular septa, and it is these septa that constrain the lateral compartment. It's also known as the fibular compartment for obvious reasons. I'll make them more obvious. That's an F. There is also a transverse intermuscular septum that separates the superficial posterior or flexor compartment from the deep posterior or flexor compartment, and then the whole limb is surrounded by the usual layer of deep fascia. If you're disoriented, we're looking up at our section of the right leg here, the same way we'd look up at a section on a CT scan. So here we have the lateral or fibular compartment, which contains 2 muscles. This is the anterior or extensor compartment, which contains 4 muscles. This is the superficial posterior or flexor compartment, which contains 3 muscles. And this is the deep posterior or flexor compartment, which contains 4 muscles. I'll colour them up. We can look now at the compartments in isolation, starting with the anterior extensor compartment. This most prominent and most medial muscle here is tibialis anterior. It arises from the proximal part of the lateral surface of the tibia, and its fibers extend down to a tendon that is attached to the medial and inferior surfaces of the medial cuneiform and the base of the first metatarsal. We can actually see this better in our original image. Here we have it, the tendon of tibialis anterior, which will be wrapping around underneath those two bones. Also arising proximally, this time from the fibular and interosseous membrane in this area here, partially hidden by tibialis anterior, is extensor digitorum longus. He doesn't. It splits into 4 tendons that extend down over the foot and run to the base of the intermediate and distal phalanges of the lateral foretoes. In between these two muscles peeks out extensor hallucis longus. It arises from about the middle third of the anterior surface of the fibula and the interosseous membrane here, more distally than the other two muscles, and its single tendon extends to the base of the distal phalanx of the great toe. Finally is the somewhat puzzlingly named fibularis tertius, this very small, sometimes absent muscle which arises from the distal part of the anterior surface of the fibula and extends down to the base of the fifth metatarsal, just distal to the tuberosity. Fibularis tertius, although called fibularis, is a member of the extensor compartment because it travels underneath the extensor retinaculum. This is the superior extensor retinaculum, and this Y-shaped affair is the inferior extensor retinaculum, and all the tendons from the anterior compartment travel underneath these retinacula to arrive at their destinations in the foot. So those are the 4 muscles of the anterior compartment. We'll turn to the 2 muscles of the lateral compartment now. The muscles in the lateral compartment are the true fibularis muscles. They both arise from the lateral surface of the fibula, which is the base of the compartment. This long, very strong muscle is fibularis longus. It arises from the superior 2/3 of the base of the compartment, the lateral surface of the fibula, and its very long and most interesting tendon extends all the way under the foot to the medial side, where it attaches to the inferior surface of the medial cuneiform and base of the first metatarsal. If that sounds familiar, it's because it's almost the same distal attachment as that of tibialis anterior, and this is because that point is the highest point in the medial longitudinal arch of the foot, and both these very strong muscles act to support that arch. And fibularis longus also acts to support the transverse arch of the foot along which it runs. Its smaller companion here, although perhaps quite not as diminutive as shown in this diagram, is fibularis brevis, of course. It arises from the distal half of the lateral surface of the fibula, somewhat under cover of fibularis longus here, and its tendon follows that of fibularis longus posteriorly around the lateral malleolus, but is quite short and ends here at the tuberosity at the base of the fifth metatarsal. Both of these fibularis tendons are also contained by retinacula. There's a superior fibular retinacula here and an inferior fibular retinaculum about here. The inferior fibular retinaculum is associated with the fibula trochlea of the calcaneus. We'll look at the posterior compartments now, starting with the superficial one. And we can see here the most superficial muscle in that compartment, which is the very shapely gastrocnemius muscle. It has 2 heads and 2 muscle bellies, medial and lateral. The proximal attachments are just superior to the posterior articular surfaces of the femoral condyles in this region here, and the muscle bellies are inserted into this flat aponeurosis, which thickens and narrows, if such a thing is possible, into the very large, strong tendo calcaneus. I believe earlier in the video I referred to this with the vulgar clinical name of tendo Achilles or TA. I apologise for that. The gastrocnemius shears this aponeurosis and tendon with the very flat underlying soleus muscle, which we can see just here, but to get a better look at it, we'll remove gastrocnemius, revealing the soleus muscle here. It's this large flat muscle, again tapering down to the aponeurosis and then tendo calcaneus. its proximal attachment is the soleal line on the posterior tibia, and the attachment carries on to the head of the fibula and then the posterior surface and border of the fibula in an inverted U or horseshoe shape. The soleus is the hard working muscle of the superficial posterior compartment. It does most of the day-to-day work in plantar flexing at the ankle to enable propulsion in normal human gait. The third muscle in the superficial posterior compartment is this strange fellow here, which is plantaris. Its proximal attachment is just above the lateral femoral condyle posteriorly, just above the attachment of the lateral head of gastrocnemius on the lateral supracondylar line, really. And it's either a small vestigial muscle or serves as a proprioceptive organ because of this very long ratty tendon which crosses over the soleus muscle and inserts on the medial side of the tendocalcaneus in the heel. So those are the three muscles of the superficial posterior compartment. To see the deep flexor muscles, we'll remove these two to reveal the four muscles in the deep posterior compartment. The most proximal one here is popliteus. It's related to the knee joint. Its proximal attachment is to the lateral surface of the lateral condyle of the femur and to the lateral meniscus, and its distal attachment is to the posterior surface of the proximal tibia here above the soleal line, and it has a role in unlocking the knee joint from its locked position in full extension. The three remaining muscles are the complementary flexors to the extensor muscles we saw initially. If you recall, the names of the extensor muscles were tibialis anterior, extensor hallucis longus, and extensor digitorum longus. These three are tibialis posterior, flexor hallucis longus, and flexor digitorum longus. The difference is that in the anterior compartment, the muscles were lined up in order from medial to lateral so that their tendons did not have to cross. In the posterior compartment here, the muscles have become jumbled up so that tibialis posterior is the more central and most deep of the three, with its proximal attachment over a large part of the interosseous membrane. The flexor hallucis longus muscle is the more lateral of the two remaining, here arising from the posterior surface of the fibula, and the flexor digitorum longus is the more medial of the two, arising from the posterior surface of the tibia. This somewhat scrambled arrangement of the proximal attachments means that the tendons of the muscles must cross on the way to their distal attachments. Tibialis posterior is attached to the navicular bone and the medial cuneiform, and also to other small bones on the medial side of the foot. It's a very splayed out distal attachment. The tendon of flexor digitorum longus crosses it in the back of the leg as it proceeds to its attachment to the bases of the four lateral distal phalanges, and the tendon of flexor hallucis longus runs more posteriorly in the groove on the posterior process of the talus, which carries on into the groove on the inferior surface of the sustentaculum tali of the calcaneus, and crosses the tendon of flexor digitorum longus in the sole of the foot, and it finally attaches distally to the base of the distal phalanx of the great toe. So the trick is to remember that tibialis posterior is the central muscle, and that the proximal attachments of flexor digitorum longus and flexor hallucis longus are the wrong way round. They're related to the wrong bones in the leg, flexor hallucis longus arising from the fibula and flexor digitorum longus arising from the tibia, and that means that their tendons must cross on the way to their distal attachments. It's a little bit of an ugly situation, but it seems that we're stuck with it. Returning to our complete view of the posterior compartment, the final thing to add is that the flexor compartment has only one retinaculum, the flexor retinaculum that controls the tendons of the deep posterior compartment that arises from the distal part of the tibia here and stretches down to the calcaneus and also mingles with the fibers of the tendocalcaneus. Once again, it proved a little difficult to find too many illustrative pictures of the surface anatomy of the leg. We did find this shot of a comely set of gams. The shapely contours of the superficial posterior compartment here certainly winning the attention of this resplendent warrior. Either that or he's entranced by the gorgeous pair of Manolos. Whatever the case, we thank him for his service. That's almost everything you need to know about the muscles of the leg. I hope you found that useful. Next time we'll talk about the small muscles in the foot. Until then, ka kite.